Ooh, here's a fun geometry one. Suppose that triangle ABC is similar to DEF. So that symbol in between there means that these two triangles are essentially the same up to a size transformation. So a magnifying glass or a microscope or a telescope or some kind of thing was either made to grow or shrink the other one, but all the sides are what we would call in proportion is the technical math word. All the sides have the same ratio and all the angles are identical. So it's like a map of Los Angeles compared to the actual city of Los Angeles. They're similar, but they're not identical, of course, because one is much larger. So if they are in relationship similarity of ABC to DEF, that means we've aligned them in the correct way here. And so in the first part of this, let's fill in these blanks of these problems. Side AB, which would be this side, is in a proportion to this side, right? The left-hand side is to the left-hand side. So for the first problem, we would put DE inside of that blank. And is the ratio of DE, AB to DE, is it truly 2 over 3? Well, AB was 6, DE was 9, and what is 6 over 9 but 2 over 3? So now, what if we went to AC and DF? Well, AC is 8, and DF is 12, which is pretty nice, but notice that's not simplified, right? Both the top and the bottom have a common factor of 4. So to be polite, we should really divide those copies of 4 out of those. And 8 divided by 4 is 2, and 12 divided by 4 is 3. The same ratio, 2 to 3. So now if we're going to go to the third one, which was the BC, well, BC is this part over here, also referred to as a hypotenuse. And so it must correspond to this part over here, which is the EF. I'm going to change it to orange because I don't think that'll show up very well. So that'll be BC to EF. And then notice that the ratio here would be a 10 to 15, but notice both 10 and 15 are divisible by 5. 10 divided by 5 would be the 2, and 15 divided by 5 is 3. So yet again, the ratios are the same. They're all 2 to 3. So what is the point of the matter? Always remember that when you have similar triangles, then that will always imply, that will always mean that corresponding sides are what we call proportional. Corresponding sides will always be proportional in similar triangles, and proportional just means same ratio.